So, hello again. We're gonna make a look at system so we can track where the player is actually looking based on his camera direction, and eventually we tie it up to be able to pick this gun up instead of just walking over it. So we need to address that by making our first actor component. So opening up our character blueprint. So here we will have a new component. So we will add an actor component, but we obviously need to make it first. So moving into the player blueprint folder, I'm making yet another folder here in the that I'm calling components. Components, because we will have several different ones. We will have a health component and stuff like that. But for now we're gonna make a look at component. So we're right clicking, choosing blueprint class and choosing actor component. An actor component is a reusable component that can be added to any actor. We will use the prefix of BPC. So blueprint component look at. So how do we track from the player camera? We will do that with a line trace. So we right click and hit line trace. We'll have several different options here. We're after the line trace by channel. I will not go in depth of all the different ones here, but a multiple line trace by channel basically just trace from the camera and hits all the objects that it passes through and delivers an array back. We're only interested in the first object that we hit, so we're going with this line trace. It has a start position that will be our camera. It has an end position that with some vector magic will calculate from the camera and a forward motion. And it's tracing on the visibility channel. So all the actors basically that we hit needs to have blocking value on the visibility channel. So the start position is the player camera. We don't have access to the player camera here, so we need to fix it. So on begin play, when the game begins, we need to fetch the player camera. We could do it like this, get player controller, and from the player controller we extract the camera manager, get camera manager, and it's down here, player controller, get player camera manager. So we might think about, okay, the camera manager, the player controller, what's going on here? Because the character blueprint holds a camera. So looking at the viewport, there's the camera, a first person camera. By the way, I have adapted so it's in the center. So it previously in the default template was -10 here. I set it to 0. That makes that the gun is sticking into the walls slightly more, but we'll eventually fix that when we take a look at the guns way forward in the series. But it's a better practice to have the camera in the middle, because when you look down and pivot, you will be centered. There won't be this awkward offset to the camera, and it's easier to calculate. So I set that one to 0 and resulted in removing, so this relative location on the crouch is also 0. We had -10 in the previous video. So we have this camera here in the player controller, but in the character blueprint, but the player controller always keep track on the player's current camera. So if we, for example, would move into a cutscene and use another camera, the player controller camera manager keeps track of that. So the camera manager always holds the correct, what we currently see, what the player is currently using as a camera. So this reference is good. So we can right click and promote this one to a variable and have it as player camera ref. But we will, this one is a little bit shady from a scalability perspective, because we get the player controller from player index 0. So all the players that connect end up in an array, and we just take the first position and assume that that position is what we're after. It's a little bit shady. It works in a pure single player game, but we will take the opportunity to talk a little bit about casting. So we're removing this one. We can keep this for sure for now, because we will eventually hook it up. So what is casting? Everything in the game engine is works with inheritance. So we have a code snippet, and then we can build on to that code snippet that will inherit from the previous version. It's a parent-child relationship. So we can always trickle down towards like the end goal of the C++ version of the inheritance. So we can always trickle down from a child to a parent, but we can also trickle up from a parent to a child by casting and verifying. Are you a child of this particular instance, or are you not? And that's casting. So how to begin? We're a character component. A component is always a part of an actor. So we have a special node here that is called getOwner. GetOwner. So this one spit out where this component currently is attached to, and it spits out an actor object reference. So this actor, we can check if this actor is a character and by casting. So this actor, a character, is a child component of actor. There's actually even one in between there that is called pawn. So we could so it's actor is the absolute base of something that is placeable in the world, and then we have a pawn class that is a child of an actor, and then we have a character class that is a child of a pawn. So it's a character, pawn, actor. But we can cast directly to the character. Cast to character. So then we get this if it's successful or failed. We always need to have this state here, because if the cast would fail, then the game would crash. But with this check, it would just render into nothing. So nothing would happen basically. But we know that this one is attached to a character. But it's the character, it's not the character controller. But all characters have some kind of controller. So from this character, we could actually get controller. So this one is a base controller. It's not certain, it's not guaranteed that it is the player controller, because AI can also have controllers. So we once again need to check if this controller is a player controller. So a new cast to controller, player controller, cast to player controller. So now we verify. So we're getting the character by investigating if this actor is actually a character. It turns out that it is a character, because we know that. We're getting the controller from said actor and verify, well, we have to make sure that it's actually a player controller. Oh, and we know that that will also be the case. So from the player controller, we get the player camera manager, because that is a default C++ integrated feature into the player controller C++ function. So we're only working with casting in C++ classes. That is of importance, because we could have made a cast to character blueprint player, but this would be considered to be a bad cast, because this is the blueprint version of the character player. So by doing this, we also expose everything that is attached and added to this character. And it could be vanity hats and guns and clothing and everything. Everything is read into this particular blueprint. So that is obviously expensive in the communication part of things. So we should always try to stay away from casting to a blueprint version of a class. It's a little bit more safe to do a cast to the C++ version, because it's way faster. It's not always optimal to doing so, so you can't think that C++ is always safe. It still have a cost attached to it, but we're doing this on begin play and we need some specific values, so this one won't happen so frequently. It will basically be cast one time when on the begin play of this play session. So it's fine. So we have the camera reference. So using this camera reference now, this is basically where our camera is currently located, because it's an actor object reference for the live camera that's currently in play. So we can get location. We're getting the camera location. That is the world location where it's currently located when we're playing. So that would be the start. And we're doing this on tick. Doing too many things on tick is obviously dangerous, but we need to continuously check where the player is looking. So we don't really have any option. The option would be to way later on make this into a C++ version, because C++ is slightly faster. But having occasional ticking isn't hugely bad as long as we know what we're doing. So we need to keep track of this. So we have a start position. The end position, where is that? Well, we need to trace from the camera in a forward arc. And we have a node here called get actor forward. Get actor forward vector. But this is a normalized vector. It's a 1 centimeter long little vector that is actually based from the world origo. It's not updated to be based on where I'm currently at. So we need to do some vector math here. So first we need to make this vector longer. So we have we can track for some kind of end position. So we multiply this with a float. Multiply, we don't have the float option here, so we just choose multiply and then we right click and convert this pin into a float. And this float could be hard coded here to 10,000, for example. That's 10,000 centimeters. So now we have a vector that it's based on the forward arc of the player, 10,000 centimeters forward. We could and should make this into a variable and make this view distance. View distance. For later we might want to tweak this value, so we can't hide it, hard code it into the code. And this value, as I said, it's a normalized vector and it's actually situated in the world origo 000. So we just need to do vector math of adding it to where the camera is located. So the camera is located here. So vector math is quite simple. So we just add plus. So the vector where the camera is plus this forward vector that we have added into being slightly longer would be the end position. And we can draw the bug for 1 frame. It's ticking, so we will continuously draw this line. If we test now, nothing will happen because we haven't attached the component to the player. So we need to do that. Saving this component, we're going into the player. We don't have the component here. Choosing BPC for the component. We only have 1 component currently. Adding that one. Saving and compiling. And if we test now, we will see a red dot exactly in the middle of the screen, tracking where we are looking. That is marvelous. So now we need to track something. We need to be able to tell if objects are being looked at. So we make a test object. So going into world, we create another blueprint folder here that would hold our scripted events, blueprints. So there will be several different blueprint folders in the hierarchy of the project, but as long as they are located in convenient positions, it's okay. So in this blueprint, we'll create a blueprint class, an actor. We name it BP test sphere. Opening up, making a sphere by adding a sphere. It's default white because it's going with the basic shape material. We can be fine with that for now. So we're going to communicate with objects by using tags. There's 2 different tags. There's the gameplay tags that use the gameplay ability system, and those are super duper powerful and very usable in bigger projects and in multiplayer projects. We will use the slightly more low tier tag that's tagging this specific actor with a name, so we can quickly verify if it's this or that. So clicking the root here and writing tag by having this class default marked. So the root class defaults tag, we have an array of 0 elements. We're adding an element that is interactable. Interactable. It's super important that we spell it correct here. Big or small letters is irrelevant. This tag system disregard big and small letters, but interactable. We don't need outsave. We're compiling and saving. So this has now a tag. We're going back to the blueprint component. So if we pull out from the out hit here and break the hit results, we can see we get a lot of stuff happening when we hit something. But first off, we always need to be careful here because we're doing it on tick. So the absolute first thing that we need to do is do a branch. I'm holding down B and left clicking, and if I hit anything at all, then I will check if it has the tag. But if I don't hit anything, I might be looking into the air, up into the clouds, and this distance isn't long enough, so we don't hit anything, then we shouldn't do anything. We shouldn't do any calculations, for now at least. So if we hit something, we can check, okay, what kind of information do we have here? Hit actor. So what kind of actor do we hit? Well, we can check if it has a tag. Has tag. Actor has tag. What kind of tag? Interactable. So we will check if the tag is interactable and do another branch. So if it's true, we do hit something, well, then we check if it holds the tag interactable. So if that is false, we will yet again do nothing. But if it's true, yeah, well, then we will continue. And continuing by right-clicking and promoting this hit actor to a variable. So we can save it here in our blueprint component and naming it something convenient, maybe interactable current. So what we are currently looking at. And we can also save the distance to this object. So the distance, and we could name that one distance to interactable. That is awesome. And just for the purpose of this, we do a print string, the most common debug feature. We will print hello if we do look at something that holds the tag interactable. We need to add our newly created test sphere. So I'm just jumping into the content browser, dragging it and dropping it into the game world. And if I'm testing now and looking at the test sphere, it spits out hello. And if I'm not looking, it stops. So our communication system works. We will venture a little bit deeper into the system now and start building up for having it as an interact system, so picking up and interacting with stuff. And by doing that, it's super powerful to use interface communication. So the interface communication is basically a mailman system. So we're talking to a mailman, so the mailman is delivering the information to the correct place. So it's a little bit, let's just do it. So going into P1 framework, we're making a new one called interfaces. And in the interfaces, we right click and do, let's go down here into blueprints and choose to make a different kind of blueprint called blueprint interface, and name it with the prefix BPI, blueprint interface interactable. And venturing into this one, it just open up a slightly different, confusing window where we only can create functions. We can't really code anything here because this is the mailman structure. We are delivering something to a mailman and then transferring that information into this new destination. So our first function would be an on looking at. So that's one of our mailmen. So if I'm looking at this sphere, we tell a mailman that I'm looking at you. The mailman goes to the sphere and delivers that, hey, you're being looked on. And we make another function and name it on stopped looking at. And we save it. And then we'll actually go to the test sphere, because the test sphere needs to hold a reference to this newly created blueprint that's currently in the game system, in the framework of the system. That's why we placed it in the framework. So this one is usable for all blueprints now, but we just need to implement them. So going into the test sphere, we're looking at class settings. So if we click class settings in the test sphere, we can see here implemented interfaces, no interfaces. So we're gonna add, looks slightly off. No, never mind. I'm adding an interface here. BPI interactable. I think it should have been added there. All right. So this is slightly new. It should have been ending up here. I'm slightly confused now because I'm implementing into this. This one in previous versions, we're in 5.1 now. Previous versions, this indicated that a parent had the interface implemented. So it should have been here. Is it just a bug? I'm exiting that one and opening the blueprint again. It's still in inherited interfaces. Okay, it should work anyways, so let's continue. So if I'm looking at, I can see now that I have interfaces here. So I'm right clicking on looking at and implement this event. So now I have this event here waiting for it to be triggered. This is basically the mailbox. So the mailman comes and delivers something to the mailbox, and then we can do stuff. So we're just gonna print a string. We could print hello, but we could be slightly more refined. So I'm dragging out from this pin and hitting append, writing append. So now I can append two different strings. So the first one is looking at colon, and the second one would be the name of this blueprint. So we can get that by hitting self, get a reference to self, and then hooking this one in. It's an actor reference, but we're hooking it into the string, and then it automatically gets the display name. This won't do anything because we haven't sent the mail yet. So how to do that? Well, it's not hard at all because we have the blueprint interface integrated into our project right now. So going back into the BPC look at, so this one worked. We can remove this print string, and instead we'll send a mail. To where do we send the mail? We send it to what we're currently looking at. I'm looking at you. I will send a mail to you on looking at. And the power here is we're continuously sending mails to everything that we look at, to all the actors that we're looking at, but only one actor holds a mailbox. So it's safe. So we are spamming, basically currently spamming to everything that is interactable. We're sending this mail to, but we could have done it equally so like this. Bypassing everything, and this would also work, but this would be expensive because then we just do a lot of checking and a lot of stuff and spamming it, sending mail to each and every one, but it would still work because most actors will not have a correct mailbox. Only one actor have a correct mailbox, but we're still spamming. So therefore we gatekeep with a couple of branches. So this one will work. So checking it, looking at, it worked. We're talking to this actor now. So it's the actor that is making the decisions, not the blueprint component. And that is obviously super powerful because now we can implement a lot of stuff into this specific actor, and if I'm duplicating it into another actor, that could hold different information. So now I'm looking at test sphere, and now I'm looking at test sphere 2. So these are different actors in the game world now, and they could hold different things. I've noticed that some things keep unloading for me in the when I'm not in play mode, so I can't really see it. I duplicated this sphere and it disappeared while in construction mode. So it unloads itself in the outliner. So what I did was I created a new folder here called gameplay simply, and I just moved my test spheres into that one, and then I could pin them to make them visible. And if I restarted the editor, they both became invisible. So I'm not sure if it's currently a 5.1 bug or if it's a feature of unloading and loading actors that I'm currently not fully in tune with, because it's a new behavior. But for now, this fixed it for me, so I created this. So continuing, we can talk to different objects. And moving back into here, we need to be more fine-tuned, because this works, but we want to be able to tell an object that I'm not looking at you anymore. Right now it just stops ticking, and we don't have any option to send an event telling something that you should change behavior now because I'm not looking at you. It will just be triggered once. We only have this on looking at. We would want to implement the interface of stopped looking at as well. Implement this event. So this one we would want to trigger as well. We can prepare it. We don't currently have any means to check it, but we're preparing it and changing to stopped looking at. Compiling and saving. So now we can close this test sphere because we won't need it. It's prepped. So taking a look at this, we need to do something. So we shouldn't send an event of stopped looking at to the interactable current. So we want to send it to the previous version of what we were looking at. So we need another reference here. So choosing the interactable current, hitting Control D and naming it previous. So the previous actor, and how to kind of address how to kind of save that logic needs to be dealt with. But the previous actor should send an post to on stopped looking at. So this one should be sent like this. So we can check when we have assigned these values. We can check if we can have a branch here. So if the previous is the same as the current, then we're looking at the same. Then we're looking at the same actor as we did previous tick. So therefore it's true. So what we're talking about is this. I'm Control C, Control V, and the previous one Control C, Control V. So if these are the same, pulling out and doing an equal. If these are the same, then we're looking at the same, we're continuously looking at the same target. But if they're not the same, then we should send an event to the previous one. But what is the previous one? Well, directly after we do this, we update the previous one. we're setting the previous one to the current one. This might seem weird, but we're doing it after we're sending this. So in the logic of things happening on tick, this would work. Because what happens here is the first time we're entering this sequence, nothing is set to the previous one. The previous one is null. So we're entering here, and this one receives a value. And the first tick would be that, wait a minute, these are not the same. These are different. So therefore, we're moving in here, because this one has been assigned, but this one is still null. So we're moving down here, and we're sending a stopped looking at to something that is null. So we're sending a mail to nothing. And since we're using the interface system, it won't crash. It will just deliver. It just won't deliver a mail. So it does that, and then directly after, it assigns it to the. It assigns the current value to the previous value. So the next tick would hold that these are the same. And therefore we will start communicating correctly. But this isn't fully enough, because we only get to this point if we're looking to something that is interactable. So we need to safeguard if we stop looking at an actor and moving and looking onto something that isn't interactable, we still need to send an event to the previously looked actor. We need to do it like this, actually. We can fine-tune it by double-clicking on this node and doing it so it's a little bit less spaghetti. Now we have a railroad system here. So testing this one. I'm looking at you. I have stopped looking at you. Looking, stopped. There's still a bit of a problem here, because now I've stopped looking at the sphere, but it's continuously spewing out that I have stopped looking at it. And that's not good from a performance point of view, so we need to address that as well. Because if I stopped looking at an interactable, and then I'm not looking at any other interactable for quite some time, it will just keep on spewing out that I'm not looking at it. So we need to do a do once here. We only want this one once. So we do a do once. And hooking it in like this. This one is... this almost works, but we can also see some problem here, because a do once only ever do it once. And then if we want to do it again, we need to reset it. And if we have looked at an interactable and then looked away, then we can never ever get this event again if we look at yet another interactable. So we need to unlock it at certain moments in time. So when to unlock it? Well, if we're looking at a new interactable, we need to prepare it. So right before this check here, we need to go in and reset it. But we can't drag it like this, because we can only ever have one pin going out. So we need to do a sequence. I'm holding down S. This is a flow control that basically deals with multiple options. So this one, first we go in and do this check. But we also reset this one. This should render the stop looking at to only be triggered once. I'm looking at you. We need to have this spamming, because if I'm moving away and moving too far away, we need to have some way of telling the distance to it. So this needs to be on tick. But if I'm looking away, just state once that I've stopped looking at it. Looking at you, stopped. Looking at you, and we can even intersect these, and it would work. I'm looking at sphere, test sphere, moving over, stopped looking at test sphere, and now looking at test sphere 2. It works. So that wraps it for the look at system. And we'll continue with making it a feature for our interactables and picking up the gun. But for now, peace out. Live long and prosper.